Now, what can I use this understanding of indices for? Well, I can begin to look at this whole understanding of growth and decay problems. Growth and decay problems are very important. It's a very practical application of mathematics to real world problems. And I may want to look at a rule that I might have, which would be that if the value of some investment I have, for example, might be equal to 500 times 1.1 to the power of t. Now, if we look at this to start with, there's a few things that we need to understand. First off, my equation for growth and decay using exponents is y is equal to ka to the x, where a is greater than 0, k is a constant, and x is the variable that you are changing. So thinking about this in terms of my original situation I have, 1.1 in this case is my a, and that dictates my rate. That's my rate that something is changing. My t is the power, so in this case it's time as well, and my 500 is my k. Now, the important thing to note is that if this was a time situation, at time 0, the value of my investment would be $500 times 1.1 to the power of 0. And from our indice rule, we know that anything to the power of 0 is just 1, so that would mean that my value would be $500. And this represents what we like to call our initial value. If you're thinking about it in terms of interest, this would be called your principal value. It is the amount of money that you would start off with. Looking at our question then, we might be asked to graph a certain amount of information depending on what we might be given, or we might be asked to put it in a table. And both of these methods are very easy to do using the Casio ClassPad. Let's look at our value of A though, our rate. If we said that A was equal to 1.1, this represents an increase of 10%. This comes from the fact that 1.1 is equal to 1 plus 0.1, 1 being a whole amount, 0.1 being 10% as a decimal form. If I had a value then, it was another question, of say 0.9, that would mean that that was 1 take 0.1, and that would represent a 10% decrease.